Organic chemistry. Okay, so today we are dealing with organic chemistry, and this question that we are having here came in 2021, okay, science paper 2. So the question came on B8 and it's organic chemistry. So I want you to pay particular attention from this time until the time that we are going to finish answering this question. So our question reads, the structures shown are members of one of the homologous series in organic chemistry. So we have these structures, the first one, the second, and the third. And these, according to the question, are members of what? Of just one of the homologous series. Okay? Then question A reads, give the general formula for this homologous series. What is the general formula for this homologous series? Okay? So, before we answer this question, you should know that for you to answer these questions, at least you should have some background knowledge about organic chemistry. You should understand something. So I just want to give you a quick revision, okay? So when they say homologous series, what should come into your mind? Well, you should know that we have the groups. So maybe try to think of them. For example, try to imagine as if we have the groups of people. We have this is as group A, group B, and group C. Group A has members from 1, 2, 3, 4 until 10. Group B has also what? Members. So this is A, this is B, this is C. This one has also members 2, 3 until what? 10. This one has also members and many more groups. So these groups have, each group has its own what? Members. 10 in each group. And these members, they have similar looks. The way they look, the way they behave, everything is what? Is similar. So this is how these homologous series are. We have now actual groups. We have the groups like the alkanes. When you hear the term alkane, it is one of these series. And in alkane, there are members, 10 of them. And we have groups like alkenes, okay? Alkenes. So alkanes, alkenes, alkynes. We also have alcohols or alkanols. Alcohols or alkanols and many more, okay? So each group has its own what? Members, just like these ones I gave you as an example. So these structures, they've taken them, these structures shows the members of one of these groups. They've not told us the group from which they were taken. Meaning for you to answer this question, for you to write the general formula of this group, you need to know first which group is this. Because without knowing the group, you can't know its what? General formula. Because each group has its own what? Has its own general formula. Okay? So that is very important. Okay? I think you should use this as an example. Then we go through these questions together. So, what you should know now, you should take a look at the structures. When you take a look at the structures, you are going to see and observe that these structures, all of them have this something which is similar. They have something in common. So this is OH, 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 okay? So this is going to help us know which group is this. And whenever you see OH, you should know that the group is what? Is alcohols. These are alcohols or alkanols. That is very important. This doesn't change. Each structure you see with this OH with it, just know that this member is from which group? Is from the alcohols. So this is what we call the functional what? Group. The functional group, it is a group of letters like this or symbol which is responsible for the chemical properties of that group. So it is the one which is responsible for all the properties of the members in this structure. So the general formula then becomes easy. Why? Because now we know that this is alcohol. So what is the general formula for alcohol? So the general formula for alcohol, that is it is Cn, then we have H2n plus 1 OH. So this is the general formula for what? For alcohol. This doesn't change for all the members, 10 of them in this group of alcohols. It is what? They use this same general formula. So you can use this to find the members. If you want to find the 9th member, where there is N, you replace it with 9. If you want to find the second, you replace it with 2. Okay? That is A. Then B. What is the functional group for the homologous series shown above? Okay? So what is the functional group for this homologous series? Well, I've already said. So this is B. The functional group for this is what? Is OH. Okay? I'm just from explaining. This OH is the one which is what? Responsible for the chemical properties of this group, the alkanos. So the functional group is OH. Now this OH, the name is it is the hydroxyl group, OH, which is the hydroxyl group. Okay, hydroxyl group. That's how it is called, OH. So it is responsible for the chemical properties of the group. Very important. Then we have C. It says S. Okay, S. So we have actually the names here. Okay, we have the names. So I forgot to include actually the symbols. So this is structure R. This is R. Okay, according to the question, this is R. Then this is S and this is T. So this is R. This is S, and here we have T. Okay, so R, S, T. So according to this question C, it says S, which is this one here on the middle, is used as a fuel. Okay, they use S as a fuel because it burns in oxygen. Why do they use it as a fuel? Because it does what? It burns in oxygen. Okay, so take note of this. It burns in what? Oxygen. Then write a balanced chemical equation for this reaction. They want us to write a what? A balanced chemical equation for this reaction. Alright, so we have S, which is this. This S burns in what? In what? In oxygen. So just by this term, it burns in oxygen. What should come into your mind is they are talking about combustion. Okay? Because combustion generally, it is the process involving what? Oxygen. That is basically, okay? So when you see, when you hear or when you read where they are saying it is burning in oxygen, just know that they are talking about what? Combustion, because combustion involves oxygen. And that is very paramount to understand. It is very cardinal, because without that point, you can't write the equation. Okay? Because they have not given you directly what it is reacting with. So we have this thing, which is being burnt in oxygen, meaning it is reacting with what? With oxygen. Okay? Now, before we answer, another thing that you should know, these are alkanos. One of their properties is that they undergo what? Combustion. When they undergo combustion, they have specific products every time. Okay? They have what? Specific products every time. So they always produce carbon dioxide and what? And water. So that point is also very important, because without that you will not know the products of the reaction. Okay? So in this case, what are we going to say? So we are going to say this is C. This is S they are talking about. Okay? So S, how can you derive the chemical formula from this structural formula? Well, it's simple. You count the number of carbons. How many? 1, 2. Okay? So we have 2 carbons. We have 2 carbons. Okay? Then we have hydrogen. How many hydrogens do we have? So we have 1, 2, 3, 4, 5. But for this one, because you might say 6, this is a radical. Okay? radical. So the radicals exist naturally like this. This is the radical, okay? The hydroxide. So now this radical, you cannot separate this O and H because it naturally exists like this. These two don't exist independently, okay? They just exist when they are combined. So you cannot separate them. Meaning when we are counting the number of hydrogen, you leave this alone. You count the rest. It is 1, 2, 3, 4, 5. So it's going to be C2H5 here. And then you include this what? This OH, okay? So this is how we derive it. Then, because it's combustion, it is being burnt in oxygen. It means it is reacting with what? With O2, okay? To form what? Okay? So, what are the products? I'm from explaining that this is combustion. It produces carbon dioxide and what? And water. That doesn't change for alcohols. Even if we used R or we used T, it is still going to produce carbon dioxide and what? And water. So you should know that each and every time for alcohols. So it's going to be, the products will be carbon dioxide plus what? H2O. This is water, okay? Now they want us to write a balanced chemical what? Equation. So we need to balance it up. So how do we balance? Well, if you want to balance, you consider the number of atoms here, okay? The number of moles here should be same as the number of moles here, even on the product side. So for this case, we have how many carbons here? We have 2, okay? We only have 2 carbons here. When we come this side on the products, how many carbons do we have? We only have 1. So if we add a 2 here, it means it balances. Here we have 2 what? Carbons. Even here we have 2 carbons, okay? When we look at the at hydrogen on the reactants here, we have how many hydrogens? 5 plus 1 here, okay? So we have 6 hydrogens in total. What about here on the products? Well, we only have 2. So what can we do? How can we manipulate this so that we have 6? Because here we have 6 total. Even here. So if we add a 3 here, it means we are going to have this 3. When you add it at the front, you multiply with this number here, okay? So it's going to be 3 multiplied by 2, which will be 6. And when you add the number at the front, it affects everything. So it means even this oxygen is affected by this 3. So for hydrogen, it will be 3 multiplied by 2, which is 6. Meaning hydrogen has been balanced up 6, even here 6. What about oxygen? Well, for oxygen, we have 2 here, plus this one, 3 on the reactants. On the products, where is, I mean, how many oxygens do we have? Okay. Well, on the products I have, so we are going to count. This is 2 hydrogens multiplied by 2 here because 2 is affecting everything. So it's gonna be 2 multiplied by 2. It is 4 plus this 3 because even this one is affecting everything. So it will be 2 multiplied by 2, 4 plus this thing here, this 3. Meaning we have 4 plus 3, which is 7. So we have 7 oxygens on the products. But here we only have 2 plus 1, 3. What can we do to make sure that even this side it is 7? So if we add a 3 here, it's going to be 3 multiplied by 2, which is 6, plus this one here, it is 7. By this, it means this is what? Is balanced. Okay? It means this is balanced. Then you need to include the state symbols. Okay? And for the state symbols, this is water, it's a liquid. This is carbon dioxide, it is a gas. Oxygen is a gas. This is alcohol, okay? And it is what? It is in aqua state. Okay? So that is it for this question. Then, for the last question, which of the compounds R, S, or T would have the highest boiling point? Which one would have the highest boiling point? Well, one thing you should know, for this one, what determines is the carbon chain. Just go on the structures, look at which one is having the longest carbon chain, which one is having many carbons, okay? So in this case, this one has 1, this has 2, this has 3. So this one has the longest carbon chain. It has 3, meaning it is the one with the highest boiling point. That is the concept. So for D, it is what? It is T. If they ask you to give the reason, you say because it has the longest what? Carbon chain. So it's going to need more heat, more energy in order for these carbon chains to be what? To be broken down. Hence the boiling point is what? Is highest for T, okay? So this is it. Make sure you subscribe for more exam questions that I'm going to be answering, okay?